So for day 3 of Unit 1, we're going to be talking about limits again. We introduced them yesterday, probably confused you a little bit, but we're going to move on today and it's going to become a little bit more clear. So for the first 3 examples in our warm-up, we're just going to do a little bit of algebra. And there's a method to my madness that could be helpful for you later on. So for the first one, we've been asked to simplify. I have a cubic. And so I'm going to expand that. So if we know our rules of cubics, we have 125 plus, let me just backtrack for a second. Some of you would write out 5 plus h 3 times and FOIL it and expand it and so on. I'm using the Pascal's triangle, and I'm thinking first row, second row, third row, to be able to expand that quickly. So if we have something uglier, we've kind of got that in place. So I am looking for the third row, which is 1331 as my coefficients. I have all of 5 cubed for the first term, plus 5 squared and an h for the second term. I have a 5 and an h squared and a mess for the last, and all of the cube goes onto the h for that last term. Subtract 125, okay, all over h. Let's write it so we can read it. We have 125 plus 75h plus 15h squared plus h cubed. Subtract 125. Oh, cool. What do you know? My 125s disappear. So I have a factor of h, and I am going to factor that out, and I am left with 75 plus 15h plus h squared. I have an h on the bottom, and it's like magic that I made that example on purpose to simplify to 75 plus 15h plus h squared. Sorry for the messy writing. B. So first thing that we need to be able to do, by the way, is to expand. That can help us simplify things big time. We just need to remember our rules for expansion. The second one, what I see is that we have a fraction within a fraction. Rational is just gone bonkers. So I want to deal with common denominator thinking. And that can simplify things immensely. So if you have written the other example down, I'm just going to erase a little bit. All right. So I don't like that rational within a rational, so I am going to write it as mess times 1 over h, and just kind of separate that a little bit. If I have denominators of 4 plus h and of 4, then my common denominator would be 4 times 4 plus h. So common denominator thinking would be I have to change the numerator of the first one to 3 times 4. I change the numerator of the second one to 3 times 4 plus h. And when I expand the top, I have 12. Subtract 12. Oh my, that's just crazy. Over 3h, 4 plus h, times 1 over h. So exciting, the 12s have disappeared, and I have an h in the numerator and an h in the denominator, and it crosses out, which is just amazing. So I am left with negative 3 over, and expand if you wish, but it's 16 plus 4h. That's just really quite lovely. Okay. Another type of simplification that can just make your life a whole lot easier is when we have radicals. We don't like that. And day 1, we talked about rationalizing the denominator. We're going to rationalize the numerator for this one, just to be a little bit tricky. I am going to rationalize okay. So in order to deal with that root of 9 plus h, I am going to multiply by the conjugate. So let's write that out again. If I want to deal with a root sign, then my best bet is to multiply by the opposite, which would be root of 9 plus h. Add 3. 9 plus h. Add 3 so that I am in fact multiplying by 1. If we were to simplify this thing, it's like we're FOILing. But if I am multiplying those, I end up with 9 plus h. Outside, inside cancel, negative 9. The denominator is still kind of ugly, and I'm just going to leave it like that for a moment. If you notice on the top, you have a 9 and you have a negative 9. Cool. So I'm left with an h, and I am dividing h by h in the bottom. So I end up dividing out those as well. Sorry, they just crossed off. That was just silly. Okay, final answer. 1 over root of 9 plus h, subtract 3. So we're going to keep a record of those 3 helpful hints as we look towards limits. So yesterday we talked about limits, what a limit is, and we defined tangent in maybe a slightly different way. But if we take smaller and smaller intervals of secants, we will approach the value of the tangent. And so we can say in the limit, as that interval gets smaller and smaller and smaller, we will get the slope of the tangent. So we want to use limits to determine the slope of the tangent of the curve f at x equals negative x squared plus 4x plus 1 at x equals 3. So our definition would be the slope of the tangent is the limit as h approaches 0 for the function at a plus h, subtract f at a, so we've got the difference quotient, and the limit as that interval gets smaller and smaller should be the slope of our tangent. Here we go. The limit as h approaches 0 for this specific function is, at x equals 3. My function was negative 3 plus h squared plus 4, 3 plus h plus 1. There's my function. Subtract, I'm sorry to do this wraparound with the smartboard, the value of the function when x equals 3. Because I'm running out of board space, I'm going to put a value of x equals 3 into the function, and I will get a value of 4. Just FYI. Okay. All over h. Okay. All right. Here's where we want to simplify some things. If right now I put a value of 0 into this function, I'm going to get 0 over 0, and it's not going to be very helpful. So I'm going to tidy that up as much as I can first. So I'm writing out the limit again. I haven't looked at the limit, I'm just writing down my definition. So to tidy this up, I'm going to have negative, and I'm going to square that. I have 9 plus 6h plus h squared plus 12 plus 4h plus 1, subtract 4, all over h. The limit as h approaches 0. Okay, I've got negative 9 plus 12 plus 1 is negative 4. Right, all my numbers cancel out. I get a 0, so negative 9 plus 12 plus 1, subtract 4, all gone. I've got 6h and 4h, so I have got negative 6h, I'm sorry. I've got negative 2h, I've got negative h squared, and I have that over h. Still, if I just pop a 0 in for h, I have 0 over 0, and that's not helpful. So I'm going to continue to simplify as far as I can. The limit as h approaches 0. If I factor out an h, I have negative 2, subtract h over h. Ta-da! I have divided out h from top and bottom. I have gotten rid of that difficulty of 0 over 0, and now I'm just going to substitute h is 0 at this point. So I don't have to write the limit as h approaches 0 anymore. I just put a 0 right here, and I am left with negative 2. The slope of the tangent is negative 2 at the point 3, 4. Let's do another example together. Using limits, determine the instantaneous rate of change at 2, 6 for the function f at x equals 3x plus 6 over x. So my definition is the slope of the tangent is the limit as h approaches 0 for the function at, well, technically, 2 plus h, subtract f at 2 over h. For this particular one, I am looking at the limit as h approaches 0 for 3 times 2 plus h plus 6 over 2 plus h, subtract f at 2, which we happen to know is 6, all over h. So that is quite messy and not very helpful to find the slope of the tangent. So I am going to use some of the strategies we used before. I am going to write my times 1 over h way over here because this guy is a little bit ugly. Okay. I am going to find a common denominator. So for the top, I have denominators of 2 plus h and 1, so my common denominator would be 2 plus h. That first numerator stays the same. I'm just going to expand it. 6 plus 3h plus 6. Subtract. The second numerator becomes 6 times 2 plus h. Okay. Tidying up. I have 6 plus 6, take away 6 times 2 is 12, gone. I have 3h. Subtract 6h over 2 plus h, all times 1 over h. Okay, so that and that and that are gone. Almost done. The limit as h approaches 0. I can factor out an h. Well, I can factor out a 3h if I wanted. 1 subtract 2. Why did I not tidy that up? Nobody knows. Let me tidy that up. That was just silly. Negative 3h over 2 plus h times 1 over h. I notice a factor of h on the top and h on the bottom. So I'm going to be able to approach a value. Limit as h approaches 0. I can now just substitute a 0 right there because I've gotten rid of the 0 over 0 problem. If I substitute that anywhere along the way previous, I would have 0 over 0, which is called the indeterminate, by the way. Means we can't find if there's an answer or not, we just don't know. Okay, put a 0 in there. I have negative 3 halves is the slope of my tangent at the point, can't remember, 2, 6.